case. All right. So the division algorithm looks like this. F of x equals d of x times q of x plus r. So you may be asked to write x cubed minus 1. That's your function. Let's just say this is your function. All right. X cubed minus 1 equals d of x is your divisor. Q of x is your quotient. What about r? What is that? R represents the remainder. All right. For this particular problem right here, the d of x is your x minus 1. The divisor is the x minus 1. Your sort of like your answer is the quotient. And our answer was x squared plus x plus 1. And our remainder was 0. All right, so this is, if you had to write it, it would be either, it'll look like this, or sometimes WebAssign will just put f of x here. All right, f of x is equal to x cubed minus 1. So if you had to write it a certain way, that's how you would write it if they say something about the division algorithm. And again, that's up here. We discussed it last week. All right, any questions about that? We're going to continue to practice. This says go to checkpoint. Go to the checkpoint. I'm going to write out what the checkpoint said. We're not going to go to the book. Did I do an example? I don't know. But let me write this one down. Let's do this one first. Use synthetic division to divide 5x cubed plus 8x squared minus x plus 6 by x plus 2. All right. Which method are we using?
Synthetic.
Synthetic. All right. For synthetic, we need to know what our k is. All right. So here, we put it in this little half of a box here. What is k?
-2.
It's going to be a -2.
True. And if you didn't know that, then you could easily just set your divisor to 0 and solve for x. If you solve for x, it'll tell you that x equals -2. This is the same thing as saying x equals k. That's our k. All right. Now, what do we put along this row here?
3, 8.
First number?
It's 5.
5. All right. So we're doing all of the coefficients and the constant. 5, next number.
8.
8, next number.
-1.
Next number.
6.
All right. What if we were missing a term?
You'll put 0 in that place.
You put 0 in that place. All right. First step, we're going to bring down the 5. I always bring down the first number. All right. Someone other than Alicia, Kenneth, and Nakiria, what do we do next? What do we do next? Someone other than Alicia, Kenneth.
Multiply -2 and 5.
Very nice. And we get -10. All right. Then what's the next number? Someone other than Monisha, Kenneth, Alicia, and Nakiria. What's the next number you're supposed to write down? All right. Other than Monisha, Kenneth, Alicia, and Nakiria. I want to hear from all of y'all.
You add 8 plus -10,
Yep.
and it'll be negative
And
2.
what? Very nice. -2. Then we multiply again. We get
4.
4.
4.
Then we add. We get
3.
3.
3.
Then we multiply. We get
-6.
-6. Very nice. That last number always represents the
Remainder.
Remainder.
remainder. Yes. All right. So we did just divide. All right. Now, when we have a remainder of 0, that tells me a lot of things. One, if we get a remainder of 0, that tells me that -2 is a solution of this right here. It also tells me that -2, 0 is, what is, if it has -2 and there's a 0 there, what is it called? It's a 0.
The point.
Okay, it's a point. What's so special about it?
X-intercept.
It's X.
It is an x-intercept. It is a 0. It is a solution. However you want to call it. It all means the same thing. -2 is a solution. -2 is a 0. -2, 0 is an x-intercept. So that's a point on that graph. If we graph 5x cubed plus 8x squared minus x plus 6, your graph will go through -2, 0. It will cross the x-axis at that point. All right. Now, what if I'm asking more questions. Write out the complete factorization. Write the complete factorization of 5x cubed plus 8x squared minus x plus 6. Then 5x cubed plus 8 squared minus x plus 6 equals, so far, this is what we learned. X plus 2 is a factor. We know that because when we plugged in -2, we got 0 as the remainder. What else is a factor? We came up with something here. What else is a factor? How do you write
X
that?
plus 5.
5x squared
5x
minus
squared.
2x
5x squared minus 2x
plus 3.
plus 3. Right. That's a quadratic or trinomial. I wonder, is it factoral? Is this factoral? Can I keep going? Sometimes we can't. Sometimes we can't, but let me think about it. Is it factorable?
Yeah.
Think so? All right. I don't know. What y'all think? Okay, let's guess on some factors. All right, AC method, it'll be 5 times 3 is 15. Factors of 15 that add to -2.
3 and 5. 3 and -5. Okay.
3 and -5. But then that would give us -15. Y'all see what I mean? I don't think. Yeah, yeah, you're right. Yeah. Yeah, we figuring it out together, so don't feel bad. I wanted it to work out, but I don't think it's factorable. All right, so but this is what it tells us, that x plus 2 times 5x squared minus 2x plus 3 are factors of 5x cubed plus 8x squared minus x plus 6. If you really want to check, you could multiply all that, but we're not going to do that. All right, I was just throwing out a question. It had nothing to do with that example, to be honest. But I want y'all to understand things conceptually, like not on the surface, but what does it really mean when we're dividing by the K and using synthetic division? What are we really doing? All right, let's talk about something called the remainder theorem. If a polynomial f of x is divided by x minus k, the remainder is r equals f of k. What are they talking about? It's as simple as this. They are saying that if we evaluated, let's say we evaluated this function up here. Let's say this was f of x equals 5x cubed, blah, blah, blah. If I say evaluate f of -2, evaluate f of -2. How did we do it in the past? If I ask y'all to evaluate the function.
You sub in -2 into the function.
Yep, we'll do this. 5 times something cubed plus 8 times something squared minus something plus 6. And we plug in what we're evaluating it at. So we plug in -2 in this case. This remainder theorem says you can do it that way, but you're going to end up getting this same number right here, the remainder, always, which is kind of interesting. All right, so let's prove it. We're going to evaluate it the long way. F of -2 equals 5 times, what's -2 cubed?
-8.
-8 plus 8 times -2 squared. What is that?
4.
4. Then we have a negative of a -2 right here. We're going to change that to +2 plus 6. All right, I'm put equal sign, running out of space. What's 5 times -8? Start back from the beginning. 5 times -8?
-40.
-40 plus 8 times 4?
32.
32. Then I'm going to add this 2 and this 6. That's 8. What's -40 plus 32? -8, right? We get 0. So
Yeah, my bad.
if we evaluate the function at a number, we'll get the same answer as if we just use synthetic division. The last number would be the answer, believe it or not. Let's look at another example. This one right here, it looks very similar. It's not the same though, but it looks very similar. Use the remainder theorem to evaluate the following function at x equals -2. All right. Notice they use synthetic division. All right, using synthetic division. What was the remainder? What did the remainder come out to be?
-9.
-9. So they are saying if you evaluated this function right here at -2, it's going to equal -9. Believe it or not. And then we did a check. Prove it right here. F of -2, plug it in, you get -9. Kind of cool. What else does it tell us? What's a point on this graph? Let me write that down. What's a point on this graph?
-2, -9.
Yes. All right. This and this, -2, -9 is a point on the graph. Now that, of course, is not an x-intercept. Why isn't it an x-intercept?
Because the y is -9 and not 0.
Exactly. All right, the -9, we want, if it's a 0, it'll be a 0 right there, not -9. Or if it was an x-intercept, it would be 0 right there. All right, I added this problem to your notes, y'all. So you're going to have to write this on the back. Squeeze it in somewhere. It says, show that x minus 2 and x plus 3 are factors of f of x equals 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. All right, let me ask you some questions. What's the degree of this function?
4.
4.
Fourth degree.
Very good. Other than Alicia, Kenneth, and Nakiria, what is the leading coefficient of this function?
27.
Leading coefficient. Christina?
2.
2. 2. 2. 2. All right, so 2 is the number attached to the variable with the highest exponent. That's your leading coefficient. All right, if our degree is 4, then we're probably going to have how many solutions?
4.
4.
4.
Or how many zeros?
4.
How many x-intercepts?
4.
Yeah, because they're all really the same. How many factors?
4.
4.
Probably 4. Now, how many did they kind of already give us? How many factors did they already give us?
2.
2. They gave us 2. X minus 2 and x plus 3. So how many do we have to find? How many remaining factors are there?
2.
2.
2. 2 more we have to find. Now, notice it says show that x minus 2 and x plus 3 are factors. So they're telling us these are factors. So what we're going to do is, let's break down this problem by using synthetic division. So let's first look at the first factor, x minus 2. What is k? If we're going to use synthetic division to break this down, what is k?
2.
2.
2.
All right, very good. K is 2. All right, tell me the numbers, the coefficients, and the constants we need to write down now.
2.
2.
7. Negative 4. Negative 27. Negative 18.
Nice. All right. So we drop down the first number 2. What's the next number?
4.
We write
Multiply.
4.
Yeah.
Yep, multiply 4. What's the next number?
11.
11, because we added. What's the next number?
22.
22, because we multiplied. What's the next number?
18.
18, because we added. What's the next number?
36.
30.
36, because we multiplied. What's the next number?
9.
11.
9, very good. What's the next number?
18.
8.
18, because we multiplied. What's the next number?
0.
0.
0. So when you get a 0, that tells us, yes, that was a 0. But we knew that because it says show. And it says show. They're telling you this is going to work out. All right. You should get 0 in the end. If you don't, you probably didn't do something right. All right. Here's a little trick. I'm not going to do this problem all over again. All right. Using the original coefficients and constants. Here's a little trick. I'm going to use this row right here. And I'm going to use this factor. What is k for this factor?
Negative 3.
Negative 3. All right. So I'm going to break this down. Now, this was x to the 4th row. So this row right here will be x to the 3rd. And now we're about to break it down to what power?
X squared.
X squared. So what we write below the line next will be x squared. Now, we can deal with that x squared better than x cubed. So let's try to get to x squared as much as possible. So we're going to drop that first 2. What's the next number? We write.
Negative 6.
Yep. Now, how would I know we did it right? What should be the last number?
0.
What should be 0? Now, if we don't get 0, we know that wasn't we didn't do it right because they basically told us that x plus 3 is a factor. All right. What's the next number we're going to write down?
5.
5. Yep, because we add 11 and negative 6. What's the next number?
Negative 15.
Yep, negative 15 because we multiply 5 times negative 3. What's the next number?
3.
3 because 18 plus a negative 15 is 3. What's the next number?
-9.
Negative 9. Very good because 3 times a negative 3 is negative 9. Last number?
0.
0. We did it right. All right, we did it right. So now we broke it down to x squared. So I know right now, if we had to write this row right here with variables, it would be 2 what? What comes after the 2?
2x squared
2x squared. What comes right after the x squared?
plus
X.
5x plus 2.
Plus 5x plus 3. All right. So we just broke it down to that. So here's what we have so far. We have, let's write it up here. First off, f of x. I'm going to rewrite the whole thing back over. I know it might be tedious, but we're going to write the whole thing back over. 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. We know so far that that equals in factored form. Tell me the factors that they already gave us first.
X
X
plus
minus
3.
2.
X minus 2 times x plus 3. And then we came up with something. We just wrote it down. What was it?
2x squared plus 5x plus 3.
Yes. So is this factorable? If it's factorable, we need to break it down. Is 2x squared plus 5x plus 3 factorable?
I don't think it is. Let me see.
So as much as possible, we need to get it down to linear factors.
No, because it's a plus plus, so that means that the two factors would have to be plus plus 2.
That's okay. All right, do AC method. All right, when we multiply A times C, what do we get?
You
6.
do 2 times 3, which is 6, and then 6 minus 1 is positive 5.
Okay.
So you'll get x plus 1, 2x plus 3.
Okay. What did you say, Alicia? Say that again.
X plus 1, 2x plus 3.
2x plus 3. And x times 2x, 2x squared, x times 3, 3x plus 2x. That gives us that 5x times 1 times 3. That works out. All right. So I think we were a little fuzzy on that one. So let's let's do AC method real quick. All right. All right. So 2x squared plus 5x plus 3. Y'all know for AC method, we multiply the 2 times the 3, right? We get 6. What are the factors of 6?
6 and 1, and then 2 and 3.
All right. What factors will multiply to give us positive 6, but add to give us 5?
2 and 3.
Yep. So that's why we rewrite this as 4 terms, 2x squared. We expand the middle term, 5x, to 2x plus 3x, because that's what we got over here. But it has to equal the middle, so that's why we have to have an x on it. Plus 3. And what you can do is group here. 2x times x plus 1 plus 3 times x plus 1, which gives us x plus 1 times 2x plus 3. All right. Alicia came up with that, but I wasn't sure if anybody else came up with that, so I just went ahead and did it really quick. All right. So this is called the complete. Any questions about that? All right. This is called the complete factorization. When you have all of your factors written all out. These are linear factors. Why? Because all of them are to the first power. These are called linear factors. Now, what if I ask you another question? What are the zeros? What would you say?
X equals
Positive 2,
2,
-3,
negative
-1,
3,
and
negative 3. No.
So
Negative
how do
3
you
over
find
2.
zeros? How do you find zeros?
set it to
You
0.
set your factors to 0, all right? So we're missing one. What's the last one?
Negative 3 over 2.
Correct.
-3 over 2.
Yes. All right. So just throwing out some questions. Those are extra questions that we didn't have to do, but I know they're going to pop up on the homework. So that's why I'm asking these questions. Any questions about that? All right. So our goal is try to break, if it's higher than the second degree, we're trying to break it down till we get to the second degree and figure out where we can do anything manually, like factoring it manually from there. All right, what I'm going to do now, I'm going to go to the textbook. Let me pull it up first. 45. Get rid of that. This is from the textbook. 2.3. It says x cubed plus 6x squared plus 11x plus 6 equals 0 and x equals -3. What we're going to do is use synthetic division to show that x is a solution of the equation. So they say use synthetic division to show that x is a solution of the equation. So what do you think we're putting here? If they're saying show that x is a solution of the equation.
+3.
But it's not written this way. Y'all get what
So
I'm
you will
saying?
still put the -3.
Right, because it was in
It's
factor
giving you
form, it would
the
look
X.
like that. Y'all get what I'm saying? Then you'll solve for x. They already solved it for you. Y'all get it? They already solved it for you. They're telling you that -3 is a solution. Show that is a solution. All right. So we didn't even have to figure out what k was. They gave us. So this is x equals k. They gave us k already. All right. What numbers are we going to put up here for synthetic division?
1, 6, 11, 6.
All right, we weren't missing any terms. Okay, good. All right, other than Alicia, Kenneth, and Akira, after I write the 1, what's the next number? Other than Alicia, Kenneth, and Nakira, what should we write next?
-3.
-3 is correct. Other than Monisha, Alicia, Kenneth, and Nakira, what should we write next? All right, come on. You know I don't like
3.
calling you out.
3.
Zoe, what did you say? 3? Okay, good. All right, what's the next number other than Zoe, Monisha, Nakiria, Ken, Alicia?
-9.
Nice. Other than Kenyatta, Zoe, Nakiria, Monisha, Alicia. If you know you hadn't said anything, it's your turn.
You.
All right. What's the next number other than Christina, Ken?
Niggas.
All right. Other than Tanaya, Christina, Nakiria, Monisha, Kenneth, Alicia, Kenyatta.
0.
0. All right. All right. So we started out with what degree polynomial? What was our original degree?
The
The
third.
third.
Yep. This is the third. Okay. Why did it do that? All right. Let me see. Yep. Third power. Therefore, this is what degree when we write it out?
Second.
Squared.
Second. Yep. All right. Can I change the color on this thing? I don't even know. I don't even know how to work this. Oh, okay. Here we go. All right. So this is 1. The 1 is the coefficient for what?
X squared.
X squared. Next.
Squared.
X
Plus 3x.
Plus 3x.
Plus
3x.
3x. All right. Next.
plus 2.
Plus 2.
Plus 2. All right. So here's what we have so far. We just broke that x cubed plus 6x squared plus 11x plus 6 equals 0. And what? Give me the first factor that kind of gave it to us. What is the factor?
X plus 3.
X plus 3. What's the factor that we just came up with?
X squared plus 3x plus 2.
All right, good. Now we can manually break that one down because it looks favorable to me.
Yes.
What do y'all?
Yes.
All right. What are the factors then?
2 and 1, so x plus 2
Mhm.
or x minus 2.
X plus 2, x plus 1, 2 and 1. Yep. Now, great. The question was use that division, show that x is a solution. Now, obviously, x is a solution because we got that 0. So we took care of that. Then they said use the result to factor the polynomial completely. We just factor completely right here. And then it says list the real solutions. How do we find the solution?
Set everything to 0.
Yeah.
Correct. So we're going to set all of these to 0. So the solutions are, y'all tell me what the solutions are.
Negative 3, negative 2, negative 1.
negative 1.
Correct. All right. We did have a degree of 3, so we should have, for the majority of the time, we're going to have the same number of solutions or the same number of zeros. Okay. All right. Very good. We're going to try something else. Let's try a fraction this time. Yeah, let's go all out there. Yeah, like why not? Like math is fun, right?
Them the
Yeah.
ones that have me stuck, Dr. Thomas.
You said we was going to ease into this.
We just did, Nakari. What are we talking about now? We just eased into it. We finished the ease part. We finished with that. Now we gotta hit reality. All right. All right, so I guess I will let you choose between 47 and 48.
I say 48.
Let's just go ahead and just do 48. How about it? Yes. All right. So y'all see it. I'm about to write it down. Y'all can take a picture of it if you want to see the other ones. But I'm about to write it down. I'm gonna stop sharing. Here we go. All right, so I'm looking at my phone right here. 49, 48. 48x cubed minus 80x squared plus 41x minus 6 equals 0. X equals 2/3. Are we missing any terms?
No, ma'am.
No.
Oh, okay, we're good with that then. All right, so we're gonna put 2/3 in our little box here. What other numbers do we need to write up here?
48, negative 80, 41, negative 6.
All right, we're going to drop the 48. Now we need to multiply 2/3 times 48. Let me show y'all how to do that. Y'all, you know, I that's why I quiz y'all on fractions, right? Because I knew they were going to hit you with fractions and factoring and formulas, all right? So 2/3 times 48. So this is how I do it. I look at the bottom number 3, and I say, how many times does 3 go in 48? Isn't that 16?
6.
Okay. And then I multiply that number times that number. What is that?
32.
32.
All right. Now we add negative 80 and 32. What do we get when we add those two numbers?
Negative 48.
Negative 48. These are big numbers, huh? Now, again. The only thing that changed was the negative, wasn't it? Okay, what should we get now?
Negative 32.
All right, we're gonna add again. What do we get?
9.
Okay, interesting. 9. Now we're gonna multiply 2/3 times 9. Again, I look at the bottom number. I divide the 3 to the 9. 6. All right. So we did it right. How do you know we did it right?
But you got a remainder of 0.
The remainder of 0. Let's see if we can write this out. All right. How do I write the first factor out?
48
squared
x squared.
minus
All right. Well,
48x.
we do. Okay, x squared minus 48x. I'm going to put something in the front, though. What's the other factor?
X minus 2/3.
X minus 2/3. All right. Interesting. Let's factor this. What do you think we need to do first to factor 48x squared minus 48x plus 9? We have to get out the calculator for that one. What do you think we can do first to help us out here? Because those some big numbers. Anything you see we can do first before we go off into the...
Rid of the
It's
48.
gonna be
Okay.
3
What's that,
parentheses
Kenyatta?
4x minus 3 and 4x minus
Final
1.
GCF.
All right, say it again. Kenyatta, what did you say?
I say get rid of the 48 somehow.
Kenyatta, how can we get rid... Kenyatta, how we gonna just get rid of the 48? That's not math. Any other suggestions? Because Kenyatta just get rid of the whole problem. All right. Any other suggestions?
You take out the LCD.
Not the LCD. You said wrong acronym. GCL. All right. What is the GCL for 48x squared minus 48x plus 9?
3.
3. All right. Okay. Let me go to my whiteboard. X minus 2/3 times. We're going to pull out a 3. What goes in the parentheses when we pull out 3?
16x squared minus 16x plus 3.
Very nice. All right. It looks a little bit more manageable. Is it factorable? I don't
Yes.
know. Okay, cool. All right. I want you to do AC method on this. 16x squared minus 16x plus 3. See if it's factorable. Okay. And I'll give you 2 minutes to factor it while I work on it myself. All right. It was factorable, wasn't it?
Yes.
Yes.
Alicia was right. All right. So what were the factors?
4x minus 3, 4x minus 1.
Correct. Any questions about those factors? How she got that? Or are we okay with that? All right. Now, I don't want this fraction. Normally, you don't see fractions in your factors like this. So here's a little trick. We're going to multiply this 3 times this factor. If I multiply 3 times the first factor, what does it change to?
3x.
3x. Very good.
Minus 2.
Minus 2. Yep. See how that eliminated that strange looking fraction in our factors. So that's all you have to do is multiply times one of the factors. All right, get rid of that fraction. Notice you'll get the same 0. Isn't that interesting? You'll get the same 0. If you set this to 0, you get 2/3. If you set that one to 0, you would have gotten 2/3 as a 0. So if I say, I'm going to skip a step. If I ask you right now, what are the zeros or what are the solutions? What would you say?
2/3 is 1.
2/3. Yep, I just really said that one, right? 2/3. Next.
3,
3/4.
3/4.
Yep. And
1, 4.
1/4. All right. So again, to find zeros, you set all your factors to equal 0 and you solve for x. All right, we made it. We made it, y'all. We made it. All right. So next, why not a radical, y'all? Why not a radical? Why are we going there? Might as well go our way. All right. So the square root of 3. So I'm just going to write it down so I don't have to go back and forth and stop sharing. So let me look at my phone again. This one is number 49. X cubed plus 2x squared minus 3x minus 6 equals 0. X equals square root of 3. All right, again, other than Alicia, Kenneth, Nakiria, and Monisha, what is K when they write it like this? What is K?
Square root 3.
Square root of 3. All right. Very good. What are the numbers we're going to put next to our little box?
1.
1,
2,
2, negative 3.
-3, -6.
Yes. Always be careful though. Make sure we always have all the terms represented. We're getting a little spoiled with that. So every once in a while you may get one you're missing a term. So be careful about that. All right, we're gonna put 1 down. What's the next step?
Multiply
We have
times
the
square root of 3.
square root.
Yep, we multiply 1 times the square root of 3. That's not too bad. What is it?
Square root of 3.
3.
Yep. Yeah. Now here's where some of you gonna go like, what do I do now? Okay, what's the rule? What are we doing normally?
Just bring them both
Yeah.
down.
All right, we're adding, right? So in this case, since they don't both have a square root of 3 on it, you can't. They're sort of like not like terms. So we have to write, yep, 2 plus the square root of 3 because we can't add a regular number with a radical. All right, what's the next step again?
Multiply.
Multiply. All right, so I'm going to write it off to the side so you can see what I'm doing over here. We're going to multiply the square root of 3 times 2 plus the square root of 3. So it looks like we're distributing. All right, the square root of 3 times 2 is, what do y'all think that is?
2 square root 3.
Square root of 3.
True. Because if we can't multiply that regular number times that 3, because the 3 is on a radical, not the same. But what about the square root of 3 times the square root of 3? Now, we can do
3.
something with that. All right, both have radicals, so let me write it out loud. Y'all are right. It's really the square root of 9, and we know that the square root of 9 is
3.
3. Yeah. So let's write this down. I'm going to write the 3 first. 3 plus 2 radical 3. Now we're adding again. So what happens here? What do you think? What do you see that makes it better?
You
The
can
threes cancel out.
Yep. So we got rid of some of that extra stuff. So now we have 2 radical 3. Now what's the next step?
Multiply by square root of 3.
So I'm gonna write that out so we can look at it. So we gotta multiply square root of 3 times 2 times the square root of 3. What do y'all think?
Maybe 6.
Very nice, but how did you get that?
When you multiply, the radicals cancel until you'll have 2 times 3.
All right, very nice. Another way you can look at it is this is 2 times the square root of 9, which is 2 times 3, which is 6. All right, so we're going to put 6 here. And our last number is what?
0.
0. Which tell us what about the square root of 3?
At a solution.
Square root of 3 is a solution? Or what's another way to say it? Somebody other than Alicia.
0.
Square root of 3 is a 0. All right. Now, this was a cubic. Well, it's to the third power. So this row right here is to the what power?
Second.
Second power. But I don't want to factor that because it got radicals in it and everything. So I'm going to tell you the trick. Here's the trick. If for radicals, and you're going to learn this about imaginary numbers too, for radicals, if this, for example, square root of 3 is a 0, then its conjugate is also a 0. So I'm not sure if y'all remember conjugates. What do you think the conjugate of the square root of 3 is? So here's the word. You might have to Google it right quick. Conjugate. In math, what does that mean? So it's conjugate. What is the conjugate of the square root of 3? Any guesses?
Wouldn't it be the numbers that get you to the square root of 3?
No. Google it real quick and see what pops up. I don't know what pops up when it comes. I'm gonna Google it myself because it may not be popping up what I wanted to pop up. Okay. I'm gonna put conjugate.
Would the
Math.
conjugate be 3?
Say it again.
I said, would it be 3?
All right, I'm gonna go ahead and tell you. Since this is positive square root of 3, it'll just
Also
be negative square root of 3. That's the conjugate. So with conjugates, really you're only changing the sign in front of it. All right. So these are conjugates of each other. So there's a rule that says that for radicals, the conjugate will also be a 0. So let's test it out. How will we know that it's actually a 0 when we finish this part of synthetic division? How do we know it's a solution? How could we prove that? What's going to happen at the end?
It'll be 0.
It'll be 0 at the end. So let's see. We have first, we got 1. What should I write next?
Negative square root of 3.
Correct. What happens when we add?
They cancel.
Cancel out and you have 2.
Very nice. We have 2. Now we need to multiply. What do we get when we multiply?
Negative 2 square root of 3.
Correct. And we get 0. So We just proved that the conjugate did work. Now, what degree would this be if we wrote it out? What degree is that?
1.
The first degree.
Yep, yep. So that'll be x,
Plus 2.
right? Plus 2. All right. Very nice. Let's see what we got. We're going to write everything out. All right. Let's write it as factors. Give me one factor. Let's see what y'all got. Give me one factor.
X minus square root of 3.
X minus square root of 3. Nice. Give me another one.
X plus the square root of 3.
Nice. Give me another one.
X plus 2.
Very nice. Equals 0. So that's sort of the factored form of that original polynomial. All right. If I ask you, I'm skipping a step right now. If I ask you what are the zeros, you would say what?
Square root
Plus
of
or minus square root of 3 and then negative 2.
And negative 2. Very good. All right. Again, if they say solutions, it means the same thing as zeros. So if they ask you for the solutions, you're writing the same thing down. All right. I feel like maybe we need to do one for the road, and that's going to be it. Home division. What number?
Number 7.
All right. So this is homework number 7. Give me the divisor one more time.
It's x squared minus x minus 3
All right. Divided
divided
into.
by x squared to the third minus 17 minus 20x plus
Okay.
x to the fourth.
Hold on. All right. So I did this part right here.
Yes.
All right. And under here should be, say it again, x to the.
It should be 5x to the third minus
Okay.
17 minus 20x plus x to the fourth.
All right. Give it to me in descending order.
X to the fourth plus
Okay. Yeah.
5x to the third minus 20x minus 17.
All right. So always write it in descending order, right? Or else it's going to be all over the place. All right. Let's begin. So we're only going to look at x squared and x to the 4th. What times x squared will give us x to the 4th?
X squared.
Yep. Yep. We're missing a term.
You
Did
gotta
y'all
put
see
a
that?
0. Yeah.
Yeah. All right. You probably have to tell me what it is back over again. So plus,
Okay.
hold on, plus 0x squared. All right. What else?
Minus 20x minus 17.
Okay. And y'all have different problems normally. Some of you may have the same, but normally y'all have different. All right. So x squared times x squared. That's what we said. So we'll put it here. Now we need to multiply x squared times this. What do we get?
X squared to the fourth.
So just say x to the
Minus
4th.
x.
You're saying squared. X
Oh,
to
I'm
the 4th.
sorry.
Yeah, x to the 4th. What else?
Minus x to the third
Minus x to the 3rd.
minus 3x squared.
Minus 3x squared. Don't forget, we got to do what now, everybody?
Change the sign.
Change the signs. So that's going to be minus. That's going to be a plus. That's going to be a plus. This cancels out. All right, what are we going to write now?
Minus 4x to the third.
Is it plus or is it minus?
It's
Make sure you
plus.
change y'all might want to change colors when you change signs, right? So it's, what should I write down?
It's 6x to the third.
Yep. Plus
3x squared.
3x squared. And we should always bring down one term at a time. I'm going to start back over. So we're going to look at x squared and we're going to look at 6x cubed. What times x squared will give us 6x cubed?
6x.
All right.
2x. Oh, I'm sorry. 6x.
6x, yep, sounds good. 6x times all of this is what?
6x cubed
6x cubed.
minus 6x squared
6x.
Yep.
minus
18.
18x.
Yep. Then we gotta
Change the
change
sign.
sign. Plus, plus. So notice I put it in a different color. That might help. That always cancels. What should we write next?
9x squared.
Yep. Next.
Minus 2x.
-2.
Yep.
We bring down
Then we,
17.
yep. Minus 17. Start back over. Notice our answers going down descending order, so that kind of helps too. I know we need a constant right here. X squared times what is 9x squared?
9.
Sure is. 9. We multiply 9 times our entire divisor, which gives us
9x squared.
mm-hmm,
Minus 9x.
mm-hmm.
Minus 27.
All right. Minus plus plus. Okay. All right, that cancels. What do we get now?
7x plus
7.
10.
Plus 10. Very nice. Notice that this degree right here is lower than this one, so we know that's our remainder. We can't keep going on. Lower. So this would be plus 7x plus 10 over x squared minus x minus 3. So that's maybe one way you could write the answer. I don't know how they ask you to write it, but that's one way to write it.
Okay.
How you feel?
I feel better because I ain't know what I was doing.
That's all right. That's all right. Yep. Long polynomial long division. So you can always, and I have videos and on my YouTube channels and for Math 100. I have the most videos for my Math 100 class, and explains one of those videos explains synthetic division and polynomial long division. If y'all need a refresher, just go to my Math 100 playlist, and you'll see my videos for Math 100. If anytime you need a refresher on something you learned from intermediate algebra class, you can always do that. What's your question?
Okay, so I was going over 2.2, and you know how you said sometimes you have to use the quadratic formula for it.
Mm-hmm.
I was doing that, but then I'm confused when it's talking about the multiplicity of that one because it doesn't really break down into factors like the other ones do.
I get you. What's the function?
Hold on, let me find you an example. I went through so many.
It's probably odd multiplicity if you confused about it though. 'Cause normally, but even it's kind of you'll see a little 2 outside of your parentheses, or
Oh, okay,
if
hold
it's
on.
not outside of the parentheses, then it's probably odd.
Because you know, like how the bracket looks, or the radical, and then you fill in everything for the quadratic formula. Do you
Right. So you
behind the
really broke it
multiplicity of that
down
one? Do you
would
look
be
back at the
one.
actual formula?
If you broke it down a quadratic to 2 solutions, then you really broke it down to linear. You see what I'm saying? You really broke it down into its own factor. It's not the same factor squared after that. All right, so it's
Okay.
really one. You see what I'm saying? I want you to look for if you break it down like this, what's the number here outside of that parenthesis?
Okay,
Now,
yeah,
if
I
it's
understood it when you did it that way.
all right. So if it was something weird that you couldn't factor, but you broke it down into something like, I don't know, I'm just making it up, plus or minus square root of 2 or something, then
Yes, ma'am.
really you just broke it down into these type of factors. It's just going to be like x minus 5 plus square root of 2 to the first power, and then x minus 5 minus square root of 2. You get what I'm saying? To the
Oh,
first.
okay.
Yeah. You broke it down to the first power twice.
Okay. I was just trying to
You
make
get
sure
what I'm
because you
saying?
hit us with that on the test. I won't be confused.
All right. Good afternoon, Math 112.
Good afternoon.
No.
Hey,
Good
y'all.
afternoon.
Good afternoon.
Good afternoon.
Did y'all have an eventful weekend? Was it okay?
Yes, ma'am.
You had fun, Zoe?
Yes, ma'am.
Okay. All right. We're going to go ahead and get started. I'm going to call out names. If I do not call out your name, that means I have already marked you present for today. Justin Brown. Sophia 2. Kine. Akiria. DeAdrian. Merrick. Anaya. Kenyatta. All right. I see you, Alicia. And I see you, Christina. All right. Do y'all have questions about homework from last week or anything? Any questions from homework from last week?
I do if you got some time, Dr. Thomas.
All right. What's your question, Steve?
Um, let's see, number 8.
All right. So 2.3, number 8.
Yes, ma'am.
All right. What is it? What's the question?
All right, so it's 9x cubed minus 54x squared plus 51x minus 30 divided by x minus 5, and then you have to use the synthetic division to solve.
All right. Okay. So it's just divide. That's it. Nothing else we have to do to it.
No, ma'am, that's it.
All right. So what would be our K? Anyone? What would be K?
It'll be
55.
5.
Yep. It would be 5. And we have all of our everything in descending order. We have the third to the third power, to the second power, to the first power, and our constant. So 9, negative 54, 51, negative 30. We bring down our 9. We multiply. What do we get when we multiply?
45.
45. Then we add these two numbers together. What do we get?
Negative
-9.
9.
Negative 9. Yeah. Then we multiply negative 9 times 5 to get,
Negative
Negative
45.
45.
and then we add, we get
6.
6. Then we multiply 6 times 5, we get
30.
30.
30. All right, so our remainder is 0. We started off with a cubic polynomial. So we end up with what? What degree would this row be?
Squared.
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 X squared All right, let's see.
Oh.
Let me change this up. X squared minus 9x plus 6 would be the answer if all they wanted was to just divide it. Is that okay, Kenan?
Yes, man, that makes sense.
All right. You see your mistake?
I definitely did. I think what was confusing me is how they would like give you the X, and then they would set up the X like that, and so like they would set up the X like equals or doesn't equal a number, and then on another question they'll have like that X minus 5 in the divisor. So I think that was what was made my answer wrong.
Okay, got it. Zoe.
Okay, I had two questions. It wasn't really a homework question. It was just like random questions. So he answered one of them. He asked when he said like sometimes they'll be like they'll have the one on top, and then they'll have doesn't equal -1 over if it's 1 over 2 or something like that. So that means it does not equal that. That means you just use the regular number like 1 over 2, right? You know what I'm trying to say?
Meaning if they say x equals 5, then 5 is what you put here.
Okay. And then
Is
they
that
got
what
the
you're
little line through it, then it'll be like -5 then.
what
Like,
line?
you know when you have
Like
an equal sign,
if it
like
was
does it
6
equal?
equal to 5, yeah, if you had the
Yeah,
line with the equal
the
sign.
line through, yeah, they had them like that. Like they had the line through the equal sign.
Oh.
So, but the thing
If they did
was, I
something
didn't
like
know what
this,
that.
like they did something like this.
Yes, and I didn't know what that meant, so I kept getting the answer wrong. Like
Okay.
that's that he answered
Yeah,
it.
don't pay attention to that. They're just saying the domain can't be, I can't put a 5 down in the denominator because that's what's going to happen if I plug in 5 for x.
Zero.
It's
Okay.
going to be a 0 in the denominator. They're just saying it'll be undefined there. That wasn't even necessary. Don't even pay attention to that.
Oh, okay.
Yeah,
And I had
that's just the
another question.
domain. Yeah, that was just they just specifying the. I don't know why they did that for some of them. They
Oh,
did. Yeah.
okay. That makes sense now.
Yeah, all they're
And
saying
then,
is that you can't plug in a 5 in a situation where x minus 5 is in the denominator because 5 minus 5 will give you 0 in the denominator. That's
okay,
all it's saying. Yeah, yeah.
okay. And
It
then,
wasn't even necessary for you to work it out.
okay. And
All right, what up?
the other question was, okay, so if it say you synthetic, no, it told me to use long division. So that means we can't use synthetic division on those problems.
Yeah, anytime you have x, anything of this form, you can use synthetic division.
Okay.
How would the computer know you use? They wouldn't.
I
It
don't
wouldn't.
know.
It,
That's why
it's the
it
same
kept.
answer.
Yeah, that's why I was confused because it'll be written the same exact way, but then say use this one, use that one. That's why.
Yeah, I can
Yeah.
see if I gave you a paper test and I said
Okay.
use synthetic division, then I'm gonna look on that paper test. I'm looking for synthetic division, but on a computer, they wouldn't know the
I
difference if you use long division or synthetic division. You get the same answer.
yes, ma'am. Okay.
Hmm.
I think they were just trying to start you off, build you up on the problems, because
Hmm.
some of them at the beginning were kind of easier than others.
Right. Yeah. All right. Anything else about the homework 2.3? All right. All right. Good. Well, we're gonna move on to 2.4 today and attempt to complete 2.4 today. So let's get started. It's called complex numbers. So our objectives for today, we're going to use the imaginary unit I to write complex numbers. We're going to add, subtract, and multiply complex numbers. Use complex conjugates to write the quotient of two complex numbers in standard form and find complex solutions of quadratic equations. All right. All right, I'm gonna mute you for a second, Kenneth. Are you on campus?
Oh, I'm sorry. Yes, ma'am. I'm in
Yeah, I
the
figured you were.
planning center.
Yeah, I figured you were in near the cafeteria. All right, good. All right, consider the quadratic equation x squared plus 1 equals 0. We've encountered that before. Let's say I ask you to solve for x. What would you do first? Anybody? You can unmute
Get
now
X on
whenever
the
you.
side by itself.
How
Square.
do you
Subtract the
what?
one.
One from both
Subtract
sides.
1. Yep. Subtract 1 would be the first move. So let me do that. Subtract 1 from both sides like this. Make this bigger. All right. And so that's why they get this step right here. X squared equals -1. All right. But we haven't solved for x yet because it's x squared still. Then what would you have done
You have to
after
square
that?
each side.
Square root both sides, right?
Mm-hmm.
So you'll get something like this, and you end up with this. Now, they call I equals the square root of -1. Well, they call x equals the square root of -1, I. All right. So this is what I want you to memorize. They decided, okay, before we were like, oh, there's a negative number on the square root. We don't know what to do with that because we're in the real number system. Well, guess what? Now we're in the imaginary number system. And they define the square root of -1 as something called I. I standing for imaginary. All right. So I want you to memorize that I equals the square root of -1. Also note that if you square both sides, like so, if you square both sides, then I squared will equal -1. Does that make sense? If I equals the square root of -1, then I squared equals -1. Any questions so far? So I want you to memorize this. Let me write it over here. I equals the square root of -1. I squared equals what? -1. All right, because if you square a square root, remember the radical goes away. But we can even go further than that. Let's say I ask you, what is I cubed? We can use what we know about I and I squared. Would you agree that I cubed is the same thing as I squared times I? Is I cubed the
Yes.
same?
Yes.
Yes.
Yes. Right. Remember when you have the same base, you can add the exponents. So if we know that, then we know that I squared equals what again? What does I squared equal?
-1.
-1 times this I. Then that must mean that I cubed equals -I.
One.
All right. We can go further than that. I to the 4th power, for example. How can you break up I to the 4th? Tell me a way that you can break down I to the 4th.
I squared,
I
I
square.
squared,
I square.
I squared times I
Square
squared.
times I squared. That's a good one because I squared equals what?
-1.
-1 times -1 equals
Positive one.
-1.
+1. We can go further than that if we want to. I to the 5th power. Give me a way to break down I to the 5th.
I squared
Square.
times I squared times I.
Oh, I squared times I squared times another I. Okay. So that's -1 times -1 times I, which equals what?
1i.
I. Yep. Let's do one more. I to the 6th power. Give me one way to break up I to the 6th.
I
I
square. I
squared,
square.
I squared, I squared.
I squared times I squared. Okay, I squared times I squared times another I squared. So that's -1 times -1 times -1. Did we do that right? All right.
Mm,
What is that?
Positive I. Or I.
-1 times
it's
-1 times
-5.
another
Oh yeah,
-1.
that's negative. Yeah, I'm
What
looking
is
at it
it?
crazy.
-1 times
It'll
-1
probably
times
be
another
positive one.
-1.
No,
That's
it's a
negative
negative.
Huh?
one.
Negative one.
Yeah,
Negative
Negative
Three
one.
one.
negatives.
-1.
Yeah.
It's a
Yeah.
negative.
Oh yeah, like -1 cubed. Yeah, -1. What I wanted you to notice is that we started out with I here. Then we said -1. Then we said -I. Then we said 1. Notice we started back over. I is the first one. -1 is the second one. What do you think would have came third? So I notice.
One.
Notice the pattern.
Negative
We started with I,
one.
-1, -I. It will go back to -I, 1. It's going to repeat over and over and over again. All right. I just want to show you that it's cyclical, as that it's like a cycle. It will repeat itself every fourth I. The same answer over and over again. So I'm put dot 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 because it keeps going on and on and on forever. All right. So I want you to see this little diagram. This huge circle right here is called the complex number system. Think of it like the universe. The complex number system is like the universe. We were over here on Earth. We've been dealing with the real number system all the way up to now. We were on Earth, and now guess what? We decided we were going to go to a whole nother planet and go over here to Jupiter somewhere, the imaginary number system. So all of it together is called a complex number system. We're just working with two different type of systems. All right. Some of it is similar, but some of it is new. So we're just going to have to learn the new rules for the imaginary number system. All right. I'm going to skip that because we already kind of did some pattern recognition already. All right. So we have this definition. A complex number is a combination of a real number and an imaginary number. The standard form, write this down. This is the standard form here, A plus BI. So this is the standard form of a complex number. There is a real part, that's the A, that's what's in blue. And there's an imaginary part, that's the B, that's attached to the I. So the number that's attached to the I is called the imaginary part. And we already know that I is equivalent to the square root of -1. Here are some examples of complex numbers that are in standard form. This one, 1 plus I, for example, or 39 plus 3I. All right. If I asked you, what is the real part of this one? What number would you say?
One.
One.
1. If I ask you, what is the imaginary part? What would you say?
Oh.
Okay.
I.
Trick.
So it's one.
Which one? Yeah, it's a 1. Yep, it's a 1 in front. Consider to be a 1 in front of that I. All right, good. So here's some more examples in this little chart over here. Complex number, 3 plus 2i. The real part is 3. The imaginary part is 2. If you have a number 5, the real part is 5. B must be 0. Why? Because if you have A plus BI, then if you don't have the imaginary part, then B must be 0. If you don't see anything attached to the I. All right. So let's just say that was 5. A was 5, but B had to have been 0. All right. The next one, -6i. The real part that this time would have to have been 0, and the imaginary part is -6. All right, let's add and subtract complex numbers. To me, very similar to the real number system. It's basically, to me, like adding like terms. I don't really see the difference between this adding, subtracting imaginary numbers and adding, subtracting real numbers. So let me show you. 6 minus 4i plus 1 plus 3i is the same as 6 minus 4i. I'm gonna drop the parentheses because I don't need them in this case. What do you think we can add together? If I'm telling you, it's really no different.
The
Yeah,
6 and the
6 and
1.
1.
Yeah.
6 plus 1 is
7.
7. And then what else?
The -4.
-4i plus 3i.
3.
Which is
-1.
negative
I.
I. All right. And I try for the most part write it as the real part first and then the imaginary part. Normally I write it like that. All right. I try. Sometimes I don't, but I try. All right, let's look at B. What would I warn you to be careful about with B?
You have a
The
minus
You have to
negative.
distribute the negative.
Yes,
Negative.
yes. Be on alert, because there's a subtraction symbol here. So let's write it out. We have 3 minus 2i minus, tell me what would you write next?
Parentheses 5
Negative
minus 4i.
5i plus 4i.
Plus. Very good. I wanted to see when you drop the parentheses, do you multiply negative through that parenthesis? All right. So now we have, well, I would say, or sort of like terms. What could we add and subtract, or what are you?
3
What do
minus
you
5.
consider? What is that?
3 minus
3
5.
minus 5,
-2.
-2, and then
It'll be the 2 and the 4. -2. So it'll be 2i plus 2i.
2i plus 2i. Good. It's simple as that. We're adding and subtracting. All right. All right. So C, again, 3 plus 2i minus 6 plus 13i. So I'm going to give you 60 seconds to work on that on your own. Work on that for a little while. Let's see if we get the right answer. All right, somebody was at my door, Miss Duncan. All right, here you go. 3 plus 2i minus what? What did y'all write after the minus sign?
minus
Minus
6
6.
Minus
Yep,
13.
13.
very nice. All right, did we combine 3 and minus 6? What is that?
-3.
-3.
Negative 3. And then minus
Negative
11i.
11i. All right, very good. D, what operation is D? What operation?
Multiplication.
Multiplication. How do you know it's not addition or subtraction?
The parentheses.
Because we got the parentheses.
Parentheses are right next to each other. Nothing is in between these parentheses. So let's just FOIL it like we used to do with the real number system. It's only going to be a slight change in this, but for the most part, in the beginning, we do the same thing we normally do. 6 times 2 is
12.
12.
12.
6 times negative 3i.
Negative 18I.
Negative 18. Yeah.
Correct. Then negative 2 inside. Negative 2i times 2.
Negative 4I.
Negative 4i. And last, negative 2i times negative 3i.
6I squared.
6i squared. All right. We have sort of like like terms in the middle. Negative 18i minus 4i. Combine it to get what?
Negative 22.
Negative 22i. But we also know that I squared equals what? Told y'all to memorize what I squared equals.
Negative 1.
Negative 1. So we got to break it down to negative 1. All right, so we have 12. Let me write it all out. So we have 12 minus 22i minus 6. So we're not done because we can combine 12 minus 6. What is that?
6 minus
6
22I.
minus 22i. Yes. 6 minus 22i. All right, very good. Any questions about D? That was a little different. Anytime you see I squared, you have to convert it to negative 1. Anytime you see I squared, you have to convert it to negative 1. All right, let's look at E. Here's a question for you. We have 3 plus 2i, and we have 3 minus 2i. What are those called? These 3 plus 2i and 3 minus 2i. Give me your best guess. Best guess.
Difference
My
of
other class
sum.
didn't get it. My other class didn't get it. Let's see if y'all get it. What are your guesses? Alicia, what did you say?
The difference of sum.
You know what? They said something similar to that. That's not what I'm looking for. The word I'm
Is it
looking
that they
for.
just cancel out?
Honestly, I just brought it up last week. So
Conjugate.
maybe Nakiria, what did you say?
Conjugate.
Conjugates. All right. Conjugates. They are conjugates. All right. And if you look at the notes previous and prior to me doing this, you'll see on the next page it says conjugates. All right. So anytime you have conjugates, that's nice. When you multiply conjugates together, something nice happens. Let's work it all out so you can see what happens. All right, let's 3 times 3.
9.
All right. 3 times negative 2i.
Negative 6i.
All right. And then inner, we got 2i times 3.
6i.
Yep. And then 2i times negative 2i.
Negative 4i.
Negative 4.
I squared.
I squared.
I squared. I squared. Just like x times x. All right. What's nice about it is the middles count. Sort of like what you kind of alluded to difference of squares, right? So I get what you were saying. So that's 9 minus 4 times what?
Negative 1.
Negative 1. Every time we have I squared, we got to convert it to a negative 1. So really what we have is 9 plus 4, which equals
13.
13.
13. So here's what's nice about multiplying conjugates. Multiplying conjugates. You won't end up with an I in your answer. Notice that. You only end up with a real number. So whenever you multiply conjugates together, you only end up with a real number, not an I. So we're going to use that to our advantage in the next section. So that's why I set it up like that. All right, complex conjugates are a pair of complex numbers of the form a plus bi and a minus bi, where a and b are real numbers. Conjugates. A conjugate is where we change the sign in the middle, like this. So the only sign you're changing is the one in the middle. All right. So you kind of used to this with radicals. Remember we talked about conjugates last week when I said if, for example, 2i is a zero of some polynomial, then negative 2i is automatically a zero of the polynomial. It just, they come in pairs. For whatever reason, they both work. All right, let's look at this next one. 3i over 2 plus 4i. Remember when you had radicals in the denominator, what was the rule? If your answer had a radical in the denominator, what's the
You're
rule?
just going to use greater
You have to
than
change.
0 equal to.
Yeah. We had to get the radical out of the denominator by
You'll
multiplying
multiply
it by what?
the radical on the top and the bottom.
Yeah, what type of radical? Would it have been the same thing?
Oh, yes, I think.
The conjugate, actually.
Oh.
You've been doing this for a minute and not realizing you've been multiplying by the conjugate. So this same rule applies with imaginary numbers. There's a rule. You can't have i's in the denominator either. All right. So guess how we're going to get that I out of the denominator?
Multiply the
Mine
top
by
and the bottom.
negative 4i.
Multiplied by the conjugate, which is what again?
Negative 4i.
2 plus 4. 2 minus
2,
4.
2 minus 4i. All right. So again, conjugates. A plus bi, a minus bi are called conjugates. So from this example right here, we learn when we multiply conjugates times each other, we don't have an I. So we're going to use that to our advantage and get that I out of the denominator by multiplying the denominator by its conjugate. All right. I don't know how my little line ended up over here. All right, here we go. So let's focus on the denominator first, since that's what we're trying to work out. We're trying to get that I out of the denominator. So let's multiply 2 times 2.
4.
4.
All right. 2 times negative 4i.
Negative 8i.
Yep. 4i times 2.
8i.
Plus 8i.
Yep. And 4i times negative 4i.
Negative 4i squared, so just 4.
Negative. Say it again.
Oh, 16. Sorry.
16i squared.
16i squared. All right. Let's go to the numerator now. We'll come back for the denominator. What is 3i times 2?
6i.
Yep. 3i times negative 4i.
Negative 12i squared.
Negative 12i squared. All right. We obviously got a lot to do because I squares popped up. And what else can we do in the denominator?
You can cancel out the 8.
Yeah, let's please get rid of all that. That's in the way. So we have 6i in the numerator minus 12 times what number?
Negative 1.
Negative 1. Nice. Over 4 minus 16 times another negative 1. So I'm going to flip this 12 in the front. So in the numerator, we have a 12 plus 6i over what number so far? What's in the
4 plus
denominator?
16 is
4
20.
plus 16, which is 20. All right. Since we want it in the a plus bi form, we're going to split it up. This is the same as 12 over 20 plus 6i over 20. So we want to separate our real part from our imaginary part. All right. So we're going to reduce 12 and 20. How can we reduce 12 over 20?
By 4.
4. Okay.
No.
4 can go into 12 how many times?
4/5. You go in there 3 times.
All right, 3 times. And 20, 4 can go in
5.
20 5 times.
So 3/5.
Right. So that's 3 over 5 plus, what about 6 over 20? What number can go in both 6 and 20?
2.
2. So that's 2 goes into 6 how many times?
3 times.
And 20?
10.
All right. So we have 3 over 10. You can put the little I to the side of it, or you can, if you want to put 3I over 10, it means the same thing. All right. So this is the standard, called the standard form, where it's split up. And we'll try for the most part to write our answer like that. All right, let's look at B. We still have an I in the denominator. Someone other than Alicia, Kenneth, Nakiria, Zoe, and I don't know who else been talking a lot. Other than people who have been talking a lot, what are we multiplying the numerator and denominator by? All right.
1 minus 2I.
1 plus 2
What's
I.
the conjugate of 1
1.
1
minus
plus 2I.
1 plus 2I? So we're going to multiply top and bottom by 1 plus 2I. Because if we multiply by the same thing, it's not going to cancel the middle part. All right, 1 plus 2I. 1 plus 2I. So if we multiply the denominator by something, we have to multiply the numerator by the same thing, or else we just change the entire problem. So we have to do the same thing top and bottom. All right. Let's focus on the denominator. 1 times 1.
1.
1. 1 times 2I.
2I.
2I. Negative 2I times 1.
Negative 2I.
Yep. Negative 2I times 2I.
Negative 4I squared.
Correct. So y'all, maybe y'all haven't noticed it yet, but anytime we're multiplying conjugates together, y'all notice the middles cancel out.
Mm-hmm.
So honestly, you don't even have to multiply, do the whole 4, to be honest. You could just do the first and the last part of 4. You don't have to do the inner side of it. All right, that's just a little tip. But if you're a little shaky on that, foil the whole thing out. All right, let's look at the numerator. These are not conjugates, so we have to do foil on the numerator. All right, we have 6 times 1. What is that?
6.
6.
All right, 6. 6 times 2I.
12I.
12I.
Yep. 7, negative 7I times 1.
Negative 7I.
7I.
All right, and negative 7I times 2I.
Negative 14.
Negative 14I squared.
14I.
Very good. I squared. Negative 14I squared. All right. Hopefully y'all got this over here. I'm going to erase it. It's in my way. All right. I want you to write down what you think the next step is before I write the next step. All right. So I'm going to give you 60 seconds to work on the next step. So write what you think should go here. All right, we have 6. Did you all go ahead and combine your like terms or not? Yes.
Yes, ma'am.
What
5I.
did you get? 5i. All right. 5i. Then
Minus
also minus 14 times
negative 1.
-1. All right. Over 1 minus 4 times
-1.
-1 again. All right. I'm going to give you 60 seconds to write down the next step. All right. You might have to unmute since I muted y'all. All right. Now, did you write 6 plus 5i plus 14
Yes.
over 1 plus 4, which is, tell me what's in the numerator now.
20 plus 5i over 5.
Very nice. 20 plus 5i over 5. And then we want it in standard form, so we're going to split it up as how? How should we split it up?
20 over
20
5.
over 5.
5 over 5.
Very nice. That reduces nicely. 20 over 5 equals
4.
4.
4 plus
I.
I, because the 5's cancel out. 4 plus I is the final answer. Any questions about B? Any questions about B? Nobody? Okay. All right, let's practice a little bit more before we move on to the next part of this lesson. We're going to practice here. Multiply each complex number by its complex conjugate. Let's just practice. Make sure you got it. What is the complex conjugate of 1 plus I?
1 minus I.
1 minus I.
1 minus I. Thank you. 1 minus I. Again, the conjugate is where we change the sign in the middle. All right, so 1 minus I. So here's what we're going to do. We're just going to multiply that by 1 minus I. So I'm going to give you 60 seconds to work it out. All right, when you're finished, direct message me your answer. I want to see how many of you got it right. Direct message me. So don't send it to everyone. Find my name and only send me the answer. Only send me the answer, not everyone. Okay, Monisha, that's right. All right, Justin, that's right. Okay, Kenna. All right, Sophia two's like 2 question mark. All right, let me go ahead and tell you it is 2. All right, so again, I know these are complex conjugates, so I know the middles will cancel out. So I'm gonna do my little shortcut. I'm just gonna multiply 1 times 1 together. All right, what does that give you? 1 times 1, what is that?
1.
1. And I'm going to multiply I times I, negative I together. What is I times negative I?
Negative I squared.
Negative.
Negative I
Yeah.
squared, right? But we know that I squared equals what?
Negative 1.
Negative 1.
1, which means that's a 1 plus 1, which equals 2.
2.
You see it? All right. That negative, 2 negatives in the middle would change to a positive plus 1. All right, let's try this again. B. All right. Other than whoever answered before, what is the complex conjugate of 4 minus 3i?
4 plus
4 plus
3i.
3i.
4 plus 3i. All we're doing to find the conjugate is changing the sign in the middle or the sign in front of the imaginary part. All right. So I'm going to erase this. Hopefully you got A. I want you to multiply 4 minus 3i times 4 plus 3i. And when you're done, I want you to direct message me the answer. Okay, Manisha, you are on it today. Yes. Yes, Christina. Yes, Ashley. Yes, Kenneth. Yes, Nakiria. Very good. All right, I'll give you about 10 more seconds just in case you want to finish it. All right, Tanaya. All right, so again, you can FOIL all of it out if you want to. No problem. I just know, because we know the rule, right? That when you multiply conjugates together, the middles will cancel out, sort of like difference of squares. All right, so 4 times 4, though, I know the little trick to it. So 4 times 4 is 16. And I know that negative 3i times positive 3i is negative 9i squared. We're going to change the I squared to a negative 1, which will make this 16 plus 9, which equals 25. So if you got 25, very good. All right, I think we're good on that. Let's learn something else about the imaginary number system. It turns out, let's go over here in this box. It turns out that the square root of negative 2 times the square root of negative 3 is not this right here. This is what we're used to for the real number system. In the imaginary number system, you can't do that. If you have negatives under the radical, you have to follow this process up here. All right. So we're going to convert some radicals to i's, and I'm going to show you how to do that. So let's go over here to the left. All right. So they're saying that the square root of negative r equals I times the square root of r. How is that? Well, let me break it down for you. The square root of negative r, is that the same as the square root of negative 1 times r? Would you agree? Yes or no?
No.
Yes.
Yeah, right. Isn't negative 1 times r negative r?
Yes.
It is, right?
Yes.
Same thing. All right. Now, we learned in algebra class that you can split up a radical like this. Can we split it up? If we have one square root, we can split it up into two radicals, or we can split it up in as many radicals as we want, to be honest with you. All right. Now we know that the square root of -1 is the same thing as what?
I.
I. All right. Just I, right? So make sure you go back to page 1 again. Make sure you memorize these two. I equals the square root of -1, but I squared equals -1. All right. By the time you finish this section's homework, you will remember. All right. So we have I times the square root of R, which is just I times the square root of R. All right. So that's how they got this I times the square root of R business over here. All right. That's all that means. All right. So let's start with A. We're going to take it slow. Square root of -1 is what again? Let's practice. What is the square root of -1? The same thing as?
I.
I. All right. I'm going to ask you that about 10 times before I let y'all go today. All right. So yes, I. All right. Next, we have B, the square root of -16. We can rewrite this radical as -1 times 16. The square root of -1 times 16. Isn't that true? Isn't that the same thing?
Yes.
Yes.
Yes. Then we learn in algebra class that you can split up radicals like this. The square root of -1 times the square root of 16. All right. What is the square root of -1?
I.
I. I. And the square root of 16?
4.
4. So the answer is 4I. All right. It'll be awkward to keep the 4 second. Need to put, that's sort of like our coefficient. So we put it first. All right. Let's try another one. Sometimes you're going to write them a little different. It's okay. The square root of -3, for example. Tell me, how can we rewrite this radical? Square root of what times what?
Square root of -1 times square root of 3.
All right. All right. I always like to see the -1. So that's why you're going to see me put that -1 separate. All right. Here we go. Square root of -1 is what?
I.
Y'all gonna get tired of me asking that. Now, 3. Is 3 a perfect square?
No.
No.
Drum
No.
man.
So we cannot break down the square root of 3 anymore. So it's I times the square root of 3. And yes, this is the same thing as the square root of 3I. But here's the problem. In Weber sign, I don't know if y'all done radicals yet, but have y'all noticed when y'all put a square root or a radical and it'll just keep going on like that?
Mm-hmm.
That's not the same thing. This is not the same. All right. The I does not supposed to be under the radical. So I would recommend for something like this, see if website will accept this. Y'all have to let me know Thursday. Would they just
I
accept?
did it, Dr. Thomas. You have to hit the space button and put the I on the
Mhm.
outside.
Yep. You're gonna have to hit the space bar or arrow, the down arrow key or something, so that it'll stop going, continuing on and on forever. All right. That I should not be under the square root symbol. It's separate from square root of 3. All right. So again, let me say that one more time. That I should not be under the square root symbol. So however you do it, I'm okay if you write it like this, is what if WebAssign would accept that. So that's why you probably will see me put I's in front of radicals, so that you will know that it's not supposed to be under that square root symbol. All right, let's look at D, the square root of -8. Let's see how we can break that down. Square root of, we know it's -1. I always want to see that -1. Basically, well, how would I say it? Separated from the other numbers. So -1 times. Now, 8. Is 8 a perfect square though? Is 8 a perfect square?
No.
No, it's not. No, it's not. However, there's a rule in the real number system that talks about perfect square factors. We can't keep perfect square factors under the radical. So does 8 contain a perfect square factor?
Yeah,
Yes.
4.
4. Very nice. 4 times 2. So let's split it up into 3 radicals this time. We have the square root of -1 times the square root of 4 times the square root of 2. All right. Let's look at the square root of -1. What does it equal? I times, what's the square root of 4? What does it equal? 2 times the square root of 2, since 2 is not a perfect square. So the answer, final answer, you can write it as 2i times the square root of 2 if you want to. I've seen it like that. 2i times the square root of 2. All right. All right, so the next little part, write the complex number in standard form. Well, we'll try our best. 1, nothing's wrong with 1. We're going to write it back down. Plus, we just did the square root of -8. We said it equals to 2i times the square root of 2. So that's, I know it could be written like this. I just don't write it like this. Again, I don't want that I to kind of sneak under that radical. All right. So that's why I write
Yeah.
it as 2i times the square root of 2. But they are the same if you realize that the I is not under the radical.
I was gonna say I feel like that's very misleading, Dr. Thomas.
What's misleading?
The I being behind the radical two.
Yeah, yeah, yeah. But I did it that way because they say the standard form is BI. See how the B is in front of the I? So the number's supposed to be in front. But I'm perfectly fine with you writing it this way. 1 plus 2i times the square root of 2. All right, let's look at this. It turns out that the square root of -2 times the square root of -3 equals I times the square root of 2. All right, times I times the square root of 3. Well, we know that the square root of -2 is the square root of -1 times 2, which is this, I times the square root of 2. We know that the square root of -3 is the square root of -1 times 3, which is I times the square root of 3. Then they multiplied the I times the I together to get what?
I squared.
I squared. Then they multiplied, now that we got the negatives out of the radical, you can now multiply the 2 times the 3 together to get what?
6.
6. They converted I squared to what?
-6. I mean -1.
-1. And -1 times the square root of 6 gives you this answer. So, what's the point of all that? The point is, if you have negative numbers on the radicals, we cannot do it this way. And we can't do it that way. In the imaginary number system, you have to convert everything to i's first and then express them. Well, first express it in this form for with i's and then simplify your answer. You can't just multiply what's under the radical times each other if there are negative numbers under the radical. So that is a different rule with the imaginary number system that is really different from the real number system. If these numbers were positive, we could just multiply what's under the radical times each other. But with them being negative, we have to convert them to imaginary numbers first and then simplify. So let's practice. We have the square root of -6. All right. Let's break down square root of -6. How? How do we break up the square root of -6?
-1.
-1.
-1 times
6.
6.
6. And then the square root of -2 is same thing as?
-1.
-1 times 2.
Yep. And if you want to, you can break all of these radicals up like so. Once you get the hang of it, you don't have to do this over and over again. You can kind of just write your I down. But for now, we're in our learning stage. We're going to write everything down. All right. Square root of -1 is? I. We got I square root of 6. We got another I times the square root of 2. All right, let's go over here. I'm running out of space. What can we multiply together at this point?
The i's.
Yep. Yep. What is I times I?
I squared.
I squared. What else can we multiply together?
The 6 and the
The
2.
radicals.
Square root of 6 times square root of 2. What does that equal?
Square root of 12.
Square root of 12. Something happened there though. What happened that we have to work with right now? Square root of 2.
Square.
Well, I squared equals what?
-1.
I mean
Negative
-1.
But something else happened with this. What happened?
You gotta get the perfect square out of the 12.
Very good. A perfect square popped up when we multiply 6 times 2. It basically created a perfect square situation. So we have to write it as 4 times 3, which is -1 times the square root of 4 times the square root of 3. What is the final answer? I know. Let's write it out. Let's write it out. We got -1. Let's take our time. -1 times, what's the square root of 4?
2.
2. And we cannot break down the square root of 3 because 3 is not a perfect square. So what we really have is -1 times 2, which is?
-2. Oh, yeah, 2. Yeah. Oh, wait.
-2, you right?
Okay, okay.
All right. -2, right? -1 times 2 is -2 times the square root of 3. All right. Again, I is the square root of -1, not -1. I is the square root of -1. All right. Last page. Complex solutions of a quadratic equation. We have solved a equals x squared plus 4 equals 0. Let's try this again. We kind of alluded to it earlier, but if we were solving for x, what would we do first for x squared plus 4 equals 0?
Subtract 4.
Subtract 4 on both sides.
Very nice. Subtract 4 from both sides. That's how we get this step. X squared equals -4. But we haven't solved for x just yet because it's x squared. What will be the next step?
You square both sides.
Got square rooted. Yeah.
Square root it. That's how you're going to get the x equals plus minus. But let's break down -4. How can we rewrite the radical?
-1 and then
Yep.
4.
Yep, -1 times 4, which equals plus or minus the square root of -1 times the square root of 4, which y'all see is plus or minus 2i. All right. Quadratic equations. What are the degree? What is the degree for a quadratic equation?
Squared.
All right. How many solutions should we get normally with a
2.
quadratic
2.
equation? Because the degree is 2, we should get 2 solutions. All right, let's try this one. 3x squared minus 2x plus 5 equals 0. Where should we begin to solve this quadratic equation?
Subtract
Minus
5.
5 will be first.
Both sides.
All right, let's go over this again. Whenever you have a degree higher than 1, we can't use those linear equation methods any longer. There are other
Oh,
methods.
you got a factor.
Okay, very good. One way is to factor. So let's see if we could factor first. How would you even approach this? What was the first step if you said, I wonder if it's factorable? What would you do first to figure out if it's factorable?
A times C.
Yep, you would do A times C. What is A times C? Someone other than Alicia.
15.
15. Then we write all our factors out. 1 and 15. What else we got?
3 and 5.
3 and 5. Will it work? Will it work? Where will we have to put negatives at and all that at? Y'all see it would not work. Y'all see that? It would not work. Why wouldn't it work? Anybody can explain to me why it's not factorable?
Because you don't have nothing that's going to equal the middle, the -2.
Well, 3 minus 5 is negative 2, right?
It's the 5. The -5 and -3 ain't gonna, or +3 ain't gonna equal a +5. Oh, you want if you multiply like the
Okay.
3 and the
When you
5,
add them
Uh-huh. It's not gonna give us what?
5, a positive
5,
5.
yeah.
It's not gonna give us positive what? Okay, why does it? Okay, y'all, we pre-cal, y'all advance. Why can't we factor this? Why doesn't this work? 3 and -5. You might a
Because
smart
they
group.
won't
Come
add
on.
up to get 5.
Why are we looking for 5 though? Our middle
Because
number is
that's
-2. All right. Anybody see why we
It'll be
can't
a
factor?
-15, yeah, when you
Thank
factor
you.
3.
Thank
Yeah.
you. Thank you, Kenneth. 3 times -5 would not give us positive 15. That's why. If it was negative AC, negative 15, then it would have worked. All right, but it doesn't. Now that we realize the factoring method is not going to work out, what's another method, someone other than Kenneth,
The
that we can
quadratic
use?
formula.
Thank you, Nakiria. Quadratic formula. Someone other than Kenneth and Nakiria. What is the quadratic formula without you all looking back at the quadratic formula?
-b plus minus.
Nakiria. No, Nakiria, not you, not you. What is the quadratic formula? Remember I had y'all to memorize it and all for the first quiz? Anybody still held on to it? Oh, no. Okay.
I
X
think I
equals,
know it.
okay, what is it?
X is equal to -b plus
Mm-hmm.
minus the
Yeah.
square root b squared minus 4ac over 2a.
Yes.
I think that's right.
All right. There's a song for it and everything, stories about it. Maybe I didn't tell y'all the story about the quadratic formula. Y'all remind me next time to tell y'all the story about the quadratic formula. Maybe we can remember it. All right, let's look at B, because I think we only have time for, now we'll see. We might have time for both of them. Let's identify what A is, B is, and C is. What is A?
3.
3.
Yes. B equals,
-2.
-2.
and C equals,
5.
5.
very nice. So when we plug it in, we have X equals negative what? What are we plugging in for B?
-2.
-2. Well,
Negative 2. So I want you to kind of write it all out first. And then you can, on that second step, y'all can simplify. Plus or minus something squared. What goes in the parentheses?
-2.
-2.
-2 again. Square minus 4 times what times what?
Times
3
3.
and 5.
All right. 4 times A, which is 3, and he says C is 5. All over 2 times what?
3.
All right, 3. All right, this thing's, my color's not changing over here. 3, 3, 5. All right, this is the step where I want you to simplify. So we have X equals, what is a negative of a -2?
2, +2.
Positive 2, plus or minus the square root of -2 squared.
4.
4 minus what number? 4 times 3 times 5.
-60.
60, very nice. All over what number?
6.
6. X equals 2 plus or minus the square root of, we got to put what is 4 minus 60?
-56.
-56. All over 6. Are we done?
No.
No.
Nope. What is one thing you see we definitely got to get rid of under this radical?
Negative under
The
the
negative.
Definitely negative. Anything else you see under this radical that we got to get rid of?
perfect square.
There is a perfect square in 56. So there's a rule. If our number contains a perfect square factor, we have to get it out of there. So what is the perfect square factor? In 56. So that's when you take your perfect squares and you calculate and you divide 56 by 4, 56 by 9, 56 by 16, 56 by 25. Which one of these perfect squares can divide into 56?
2.
4.
4. All right. 2 is not a perfect square. So what are the perfect squares? Starting with 1. So maybe we need to review this. 1. What's the next perfect square?
4.
4. What's the next perfect square?
9.
9. What's the next one?
9.
16.
16. Next.
25.
25.
Next.
36.
All right. So all we're doing is 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, and so on, which is why they're called perfect squares. All right. Now we have X equals 2 plus or minus. Let's split up our radical into 3 radicals. Square root of -1 times the square root of 4 times the square root of 14, all over 6. All right, let's begin with the square root of -1. What is it? What is the square root of -1? I. Next, what is the square root of 4?
2.
2. Is 14 a perfect square?
No.
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 Nope. It's not on our little perfect square list we just wrote. So nope. So what we have is 2 plus or minus 2i times the square root of 14 over 6. But guess what? We're going to split it up because I want it in the a plus bi form. So x equals, we got 2 over 6 plus or minus 2i over 6 times the square root of 14. So which means it reduces to what? What is 2 over 6?
3.
No. Is it?
1/3.
1/3. 1/3, since that the lower number is in the numerator. Plus or minus, and then you can put 1/3 again if you want, times I times the square root of 14. There's a lot of different ways you could probably write that, but that's one of the ways you can write it. All right. So I'm going to let you go now because that's the end of class. All right. Unless you have a question for me, I'll stay behind. But other than that, I'll see y'all on Thursday. Do your homework.
Dr. Thomas, I don't really have a question about this, but I was asking since we have